We'll now get on to Newton's first law of motion. And Newton's first law of motion states that a body continues to be in a state of rest or uniform motion along a straight line unless acted on an unbalanced force. So the first law tells us if an object is at rest, it will continue to be at rest. Here in the first picture we have a book at rest, a book on the table, and this book on the table will continue to be on the table unless you sort of push it, you apply a force, and then it would move. So you require a force, an unbalanced force, to move this body. Till then the body will continue to be at rest. Here in the next picture we have a ball lying in the field, and this ball will continue to be at rest, will stay at rest unless it is kicked or there is an unbalanced force acting on it. Only then would the ball begin to move. So back again we go. A body continues to be in a state of rest unless a force, an unbalanced force, acts on the body. That was the first part of the Newton's law of motion. Now the second part says if a body is in uniform motion, it will continue to be in uniform motion unless an external force acts on it. So here we have a ball which is resting, and if we want the ball to move, we have to push it. Now if we exert a force, according to Newton's law, this body will continue moving. However, it is experience that once we set a ball in moving, we know the ball is going to stop after some time. Then what happened to Newton's first law? According to Newton's first law, it said that the ball should continue moving. Then why has the ball stopped? And the reason is this. When you push the ball, when there's a forward force, remember the ball is also experiencing a backward force. And that is the force of friction. This force exists on any two surfaces that come in touch with one another. So we have a forward force, which is the kick or the push, and we also have the backward force. As long as the forward force, which we'll call F1, and we will call the force of friction as F2. As long as F1 is greater than F2, the body will move forward. The minute the F1 becomes less than F2, the body will now stop moving. So when we set a body in motion, why does it stop after some time? Because the force of friction is acting in the opposite direction, which stops the body. We'll now learn a new property called inertia. To learn inertia, let us examine these two bodies. I have a ball A and a ball B, and from what I have drawn you can see that the ball A has larger mass and ball B has less mass. If you were to try to move these bodies, you would find that to move ball A you need a large force, but to move ball B you will need a smaller force. And the reason for this is because the mass of A is much greater than the mass of B. And hence we say the inertia of A is greater than the inertia of body B. So inertia is a property by which a body resists the change in motion. If it is at rest, it wants to continue to be at rest, and if it's in motion, it wants to continue to be in motion. So define inertia. Property of a body to resist a change in rest or uniform motion in a straight line. Objects that have got larger mass have more inertia, so we find them more difficult to move, and objects with less mass have got less inertia, and hence we find it easier to move bodies which are smaller. Why is it more difficult to kick a cricket ball than a tennis ball? Here's a picture of a tennis ball. And here we have a cricket ball. And we have noticed it's easier to throw a tennis ball. but to move a cricket ball is much more difficult. And the reason is the cricket ball has got more mass. So it has got, cricket ball has got more mass. Because it has got more mass, it has got more inertia. The tennis ball has less mass, it is lighter, and because it has got less mass, it has got less inertia. So a tennis ball will move faster when a force is applied to it, but a cricket ball will require more force. So for a cricket ball, you require a large amount of force to move it, but for a tennis ball, a small force is enough to move a tennis ball. Why are safety belts used in vehicles? So here is a small picture of a person sitting in the car, and as the car moves, the car is moving, and together with that the person also begins to move. Now what happens if the car suddenly stops? If the car suddenly stops, let's see what happens to that. Here the car stops, so this forward motion stops, the force stops, but however the person continues to move forward. This is because of inertia. So by the first law of motion says the body will continue to be in motion and the person now leans forward. Now when this person leans forward, he could hit this dashboard in the front or the seat in front and hence get injured. So we need to use the safety belts to prevent this forward motion of the passenger in case the vehicle stops suddenly. Luggage has to be tied in a moving bus, and the reason is again explained by Newton's first law. When a bus is moving, here the bus is moving and the luggage along with it is also moving. They're both in motion. But if the bus suddenly stops, now here see the bus, it stops suddenly. So the bus stops, however the luggage which is on the bus will keep moving. Because of inertia, by Newton's first law, it will keep moving, and there is a possibility that the luggage falls off the bus. So here you can see it will keep moving, it may fall off the bus. So to secure it, it's good to tie this luggage onto the bus. When a hanging carpet is beaten, the dust starts coming out. So here is a picture of a carpet, and we'll mark the dust in the carpet with these red dots, which is red specks. Now when we want to clean the carpet, we start beating the carpet. So here's the carpet kept hanging with this dust particles, and when we want to clean the carpet, we are going to hit the carpet in this direction. We're going to apply a force in this direction. Now the carpet will move away, but however, because of inertia, the dirt still remains in the same position. And this separates the carpet from the dirt. The dirt will then will fall down and collect at the bottom. This is how we clean a carpet, by hitting it. It is dangerous to move out of a moving bus. So here's a person traveling in a bus. So the bus is moving, and along with the bus, the person is also moving. Now what would happen if the man would jump out of this moving bus? Now when the man jumps out of the moving bus, the bus continues moving because of inertia, and the man too continues moving due to the property of inertia. However, the lower portion of this man's body has come to rest and it stops. Hence, after a few minutes, the man will probably fall down because this portion is in inertia, is in motion, while the lower portion has stopped, has come to a rest. So he will move forward or he'll fall forward. If I have a stack of coins, and to this stack of coins, if I hit the stack of coins here at the bottom, with a fast approaching coin, then I would find the lower coin would have shifted without displacing the rest of the coins. This can be explained in this manner. The lower coin moves away because it is hit by another coin. However, the coins that are on the top of it, due to inertia, they do not move their position. They do not change their position. They resist the change in their position and they stay behind. So after being hit, this coin moves while these coins stay in the same position. When a bus starts suddenly, the passengers fall backwards. This too can be explained by Newton's first law. In the beginning, the bus and the passengers are at rest. But when the bus starts suddenly, the bus is now in motion. But however, due to inertia, the passengers in the bus continue to be at rest. The bus moves forward, but the bodies of the passengers continue to be at rest, and hence they fall backwards. Another example that can be explained by Newton's first law of motion is when a tree is shaken, the leaves and fruits fall off. In the beginning, the tree, the leaves and the fruits are at rest. But when the tree is shaken, the branches move away, while the leaves and the fruit, due to inertia, stay back at rest and hence separate out from the branches and fall down. This is an experiment given in your textbook. So in this experiment, we have a tumbler here, and over the tumbler there is a card placed, and over this card is placed a coin. And then with the help of a hand, you exert a quick, fast force on this card. And to your surprise, what you find is it's only the card that moves away, while the coin stays where it is due to inertia and drops at the bottom. So because of the force exerted, this card has moved away, but the coin, due to inertia, remains behind and it drops to the bottom of the glass. Newton's first law of motion states that a body continues to be in a state of rest or of uniform motion along a straight line unless acted on an unbalanced force.